All right, so we should be finishing this right here. I need to go over to test for monotonic or okay, here it is. I kind of pointed this out the other day. Increasing, decreasing sequences of S and N said to be increasing if S of N is less than S of N plus 1 for all N that's going to be greater than equal to 1. So if my next term is greater than my previous term, then it is increasing. So non-decreasing means that it's going to be less than or equal to my next one. So let's say, for instance, I had an S of N that is just 5. Every term it would be 5. That's non-decreasing, right? Because it's equal to the previous term. Does that make sense? Mm-hmm. So it's constantly going to be 5. So I could say it's non-decreasing. I could also say it's non-increasing, but I haven't got to that point. And decreasing is where my term is greater than my next term. Does that make sense? Mm-hmm. So let's say my first term is 5. My next term has to be less than 5, right? Remember, alligator always eats the bigger one? Yeah, alligators. Greater than or less than. Okay. Any of the above condition hold, the sequence is called to be monotonic. 3 ways to show a sequence is monotonic. Right here, okay, where this is going to be, so algebraic using a difference. This right here minus that. So my previous term minus my initial term. I'm sorry, no, not previous. My next term minus my initial term is going to be less than 0. Okay, that would be a decreasing. Okay, subtract my next term minus my initial term. That would be increasing if it's going to be greater than 0. Algebraic ratios. Okay, for is greater than 0 for all n, show that this right here is going to be important. Okay, the S of n plus 1 over S of n. Okay, and same thing right here. This one, where this one's going to be less than 1, it would be decreasing. This would be greater than 1. That would be increasing over this. And derivative. Show that derivative related function is negative for all x that's greater than equal to 1. Okay, that would be decreasing. Remember the derivative of the function. Yes? That's the slope of the function, right? So taking the derivative of the function gives me a slope. If that's negative, it's decreasing. If it's positive, it is. Okay, these tests can be extended to show a sequence of non-increasing or non-decreasing. All right, let's take a look at first one right here. So for this one right here, so I'm going to have show that each sequence is monotonic by determining whether it's increasing, decreasing. I'm sorry, increasing, non-decreasing, decreasing, or non-increasing. Okay, so now for this first one right here, I'm going to go through and I'm going to kind of separate my fraction. Okay, so this is kind of interesting because I have variable top and bottom. I'm like, maybe, don't know. All right, so I'm going to separate my terms. Okay, so I'm going to separate my terms. So it's going to be like this. So I'm going to actually do, let me see. So it's supposed to be a n plus 1, and the other one's supposed to be oh wait, no, I'm doing the previous one, sorry. Alright, so this one is going to be here. Okay, I'm checking for this one right here. I'm going to use the algebraic ratio for this one. So for this one, using the algebraic ratio on top, I'm going to have my s of n plus 1. Okay, and this is going to be on the bottom. And s of n plus 1 means that this would be n plus 1, right? And this other one would be n plus 2. So I could use this one here where I'm plugging it in, and then from there I'm going to go ahead and try to simplify this out. So that would give me n plus 1 over n plus 2 times the reciprocal, which is n plus 1 over n. So as I rewrite that, I could actually FOIL this out, and from here it's going to be n squared plus 2n plus 1 over n quantity n plus 2. Yeah. All right, from there then we'd have to go through and try to break up my fractions. So on this one right here, by setting this up and looking at this right here, I would have to say, hey, look, I have same degree here, let's go through. I would have to make this one equal to some values, which would be a over n plus b over n plus 2 to be able to get my parts for this to break it up. Okay? Now that I got to this point right here, I'm using, which one was I using on this one? I was using the second one, algebraic ratio. Okay, so looking at the algebraic ratio of this one right here, okay, this one might actually take a little bit more work than I want to. So now let's look at one of the other ones. Okay, I'm trying to show you guys like the different ways you could actually do it. You could do each one, but some of them might actually pan out a lot quicker when I'm actually doing my test. So let's take a look at another one, doing this one. Let's try this one. There's a reason why I skipped this one first. So it's going to be s of n plus 1 minus s of n. So we're going to do this one right here. So s of n plus 1, so that's going to give me what? S of n plus 1 over s of n. No, wait, it's not over, it's minus. Sorry. Minus s of n plus 1 minus s of n. And I'm going to look to see its comparison to 0. So if it is greater than, it would be positive. If it would be less than, it'd be negative. So s of n plus 1 should be n plus 1 over n plus 2, right? Minus n over n plus 1. Yeah.
I already explained it. Did you get that n plus
Oh, right here. So from here, n plus 1.
Plus n plus 1.
Yeah, n plus 1 plus 1.
Oh.
Oh, I thought it would be n plus 1 plus 1. But that's just like the
That
same
would be
thing.
2 n's.
Yeah, I know. That's why I was kind of like. You're right, because it's just n plus 1. Okay, yeah,
So then
yeah.
how come the
So think of it like this. Here, let me rewrite it like this instead. So this is s of n, right?
Mhm.
So we're doing,
Add a big
next one's going to be s of, writing it like that. So what am I plugging into there? So my first one's just my n, right? Yes? I'm just leaving it as the function. This next one, where n is, I'm putting in n plus 1. Does that make a little bit better sense?
Yeah.
Okay, because whatever my terms are, let's say for instance is my first term. So because these were my sequences here. So my first term should be 1 over 1 plus 1, right? My second term should be 2 over 2 plus 1. Okay, does that still hold true on what I had previously? That n plus 1, right? So the previous, okay, so on the top n plus 1, okay, yeah, it's my 1 plus 1, right? Yeah, because I'm going to have the, I'll rewrite it again. So s of n plus 1, so we said it was n plus 1 over n plus 2, right? Okay, so there we go. So my second term, that's right here. Okay, so basically, whatever I get here, so for 1, I'll get 2, 3, right? Whatever my first one was, so it's 1, right? Still works out. So if I put in 1 here, and that's going to give me 2 over 3. And this is 2 over 3. If we're talking about numbers, does that make more sense now? Anyone still lost? Please speak now. Forever hold your peace. Okay, so now I'm going back to what I had. So it's going to be n plus 1 over n plus 2 minus n over n plus 1, right? So let's go ahead and common denominator this whole thing. Common denominator would be amalgamation of both those together, right? Okay, so so it's going to be n plus 1 times n plus 1, right? Minus n quantity, n plus 2, over n plus 1, n plus 2. Okay, let's do our math. So that's going to give me n squared plus 2n plus 1 minus n squared minus 2n, right? And all that's going to be over right? Okay, so now from here, what's going to happen to the top? Those go away, so I'm left with 1 over okay, so now for this one right here, so now I have broken it down. I only have my n's there now, right? So since I now only have my n's, can I, when I start plugging things in, what's going to happen? Okay, so let's start plugging in ones. Is this going to be greater than 0 or less than 0? Okay, because I'm starting at lowercase n. My integer that's going in is going to be 1, right? Starting with 1 and going with my counting numbers after that. So as I'm plugging this in, so now I have a clearly I could actually say, oh, hey, that's going to be a positive, that's going to be positive. So this is going to be greater than 0. Okay, so now using that information, that is now greater than 0. So that means what?
It's increasing.
It's going to be increasing. Ways to show sequences monotonic. These tests can be extended to show sequences non-increasing, non-decreasing. So for this one, we know that it is going to be increasing now. Monotonic. Okay. It's not bad, right? but I started with the ratio test. So ratio test. Yeah, the ratio, and it didn't come out very good. It didn't actually look very pretty. So I didn't like that. Okay. All right, so next one. Okay, can I erase this? Because I used the whole thing. So next one. So what are we going to have here? Yeah. Want to do the ratio? Because I'm not going to do a derivative of a factorial, right?
How do you do that?
Okay, so let's do this as a ratio. So this is going to turn into s of n plus 1, which is e to the n plus 1 over n plus 1 factorial over e to the n over n factorial. Okay, I'm going to do some creative math here. Okay, I'm going to do some creative math here. So, what does factorial mean?
All the numbers in the sequence are multiplied by integers between.
Okay, yeah. All right, so it's basically, if I did like a 3 factorial, that means 1 times 2 times 3. Okay? So given that information, let's do a little bit of algebra on this. So that n plus 1. N plus 1. So to my exponent of n plus 1, can I break those apart? Say yes. I can break them apart because I know that x2 times x3 gives me x5, right? So could I also rewrite that as x to the 2 plus 3? Yes, I can. I could rewrite it like that. So from here, can I separate that? Algebraically, I could separate those. So I'm going to say that this is going to turn into, it's going to be e to the n times e to the 1. Okay, there's a little bit of algebra there. Over n plus 1 factorial. Right? Okay, so if I start putting in counting numbers, so this would turn into, on the bottom, let's take a look. So if it is, so it would be n plus 1, right? So if I plug in 1, that would give me 2, right? Okay, and then 2 should give me 3, right? Okay, so it's going to be like this, but then it's all the terms in that, okay, going on. Okay, so that's going to be right here. I'm going to write this out. So it's going to be like n plus 1, n plus 2, right? Factorial. Because it's going to keep going and going and going, right? And each time that term is going to go up, right? So as the n goes up, it's still multiplying it out, right? Actually, it goes the other way, doesn't it? Nick,
Yeah.
why'd you tell me the wrong way?
I said n plus 1 times n factorial.
Yes, thank you. So it's n factorial times n plus 1 factorial.
I don't think it is a factorial.
Yeah, it's wrong.
It's wrong again?
Just n plus 1 without factorial.
Oh, okay, because I already have the n factorial, right?
Yeah.
Dang it.
Yeah, that'd be a calculus.
I know, that would be.
Yeah.
There we go.
E to the n factorial.
Okay.
Oh my god.
Because I have my first term and then it keeps going down right from there, right? Okay, good. Okay, there's my e to the n over n factorial. So from there, I'm going to divide those, right? So I have fraction over fraction, so divide those. So when I divide those, That's going to turn into this. E to the n times e over n factorial n plus 1 times n factorial and e to the n. So what's going to happen now? Now that I have this set up as a ratio, e to the n's and n factorial, I'm left with e to the first over n plus 1, right? So, is there an n over my e anymore? Okay, so now for this, we're going to show for all n's that are going to be greater than or equal to 1, so this value, is it going to be less than 1 or is it going to be greater than 1?
Well, once n is greater than e, it's gonna be less than, but when it's less than e, it's gonna be greater than.
So,
It's non.
okay, because 1, it'd be e over 2, right?
Mhm.
So this could be e over 2. Next one's going to be e over 3, e over 4,
Which can be less than 1.
Yeah.
okay, right there, which is should be less than 1. So for those ones right there, we're going to say that those are going to be less than 1. So less than 1, so this one would mean what?
But at 1, it's greater than 1.
Mm-hmm. So that's my issue, right?
Yeah.
So it is going to be a decreasing sequence, but at 1 it's not.
It's okay.
But at 2, from n is going to be 2, n is going to be greater than equal to 2, it would actually be true for that. So over the sequence, it's not right in the first place, but on all the further ones past that, it will be decreasing. Actually, yeah, it's all going to be decreasing here. Yes? All right. They actually say that exact same thing. So, because right there, where n is going to be greater than or equal to 2. All right, so for the sake of argument, I am 15. Do I have to do this one? Well, okay, so I'll read through this. So there's an example of monotonic sequence that diverge and examples of bounded sequences that diverge. Okay, we did one the other day. So a bounded sequence that diverged. What was that? Do you remember the problem we did? It diverged, but it was bounded. It was the cosine, right? The cosine was 1. It was bounded. Okay, it was bounded, but it wasn't going to converge. Okay, so it was divergent. Okay, a sequence that is both monotonic and bounded always converges. Okay, sequence that is both monotonic and bounded always converges. An increasing or non-decreasing sequence that is bounded from above converges. A decreasing or non-increasing sequence that's bounded below also converges. That goes to that question which you guys were asking the other day. What if it only your e or your epsilon is only one-sided? Okay, so that means it would be like bounded above or bounded below. Remember, someone was asking about that, the epsilon, is it going to be plus and minus all the time? If it's not going to sandwich it in between my two things because it's not going up and down, it's going to be bounded from one side, going to that number. Does that make sense?
Are alternating functions polytonic?
Huh?
Is that a thing? Polytonicness?
Polytonic. Monotonic? I don't know. Yesterday I was quite catatonic. Polytonic. Yeah. There's another term for things that are not, that is,
Coma?
but yeah,
Are those alternating functions?
we're gonna have different stuff. There's also the and I can't remember right now if we are gonna be dealing with those weird things. There is some that is actually like super weird that has to do with the different types of like Taylor series. That's like quite specific, and that's gonna be later on in this chapter. Okay, so we got this one right here. In words, a bounded monotonic sequence converges. Basically, okay. So, use those same tests that we just did.
In words.
Yeah, use these same tests right here to actually prove those same things. All right, I'm gonna stop this one.